As we've seen, the camshaft position sensor is just one of many that can cause the check engine light to come on. We have a 1995 Ford Explorer with an O2 sensor trouble code that we will take a look at. But first, let's talk about some of the other sensors and what they do.
Well, after the test drive, the check engine light stayed off, and that's telling me that the camshaft sensor is an intermittent fault. What that means is right now the problem's not there. A lot of times if you'd have a defective sensor, you'd have a hard fault code, and what that means is the check engine light would immediately come back on and the trouble code would come back into memory. So the thing to do now is just to keep an eye on it. If the light comes back on, we'll have to go farther into the all data system and troubleshoot and find out where our problem is. You know, the camshaft sensor is one of many input sensors that the computer uses. It uses the sensors and then it commands like an output. For example, like the fuel injection system or the ignition system. If we'd have a bad camshaft sensor, well, for example, here's one right here. Now, if you look at this, it's really pretty basic. This is a magnetic sensor, and the way this works is real simple. Now, this is a two-wire sensor. There's two wires to the sensor itself. But there's a trigger wheel on the camshaft. Either you'd be on a camshaft gear, it could be on the camshaft itself. As that reluctor comes around, it breaks the magnetic field, and that input is sent to the computer so the computer knows where the camshaft is. Now that's relative, for example, like to the fuel system, when to activate the fuel injectors. But the camshaft sensor is one sensor. Another sensor we have, now this is the crankshaft sensor. Now if you look at it, they look totally different in design, but they basically do the exact same thing. The crankshaft sensor even has the bracket that comes with it. This makes it vehicle specific. Now this is a three-wire sensor as opposed to the two-wire sensor. That's where the wiring diagrams in the all data system would come in handy, where to check the different circuits. Now if you look at this, it's also a magnetic sensor. It's not as strong as our camshaft sensor is, but the same thing applies. It's got a reluctor that comes around and it triggers or opens the circuit. Now the information from the crankshaft sensor, for example, would be used for spark to tell it where each one of the different cylinders are in accordance to like the compression stroke where it's going to fire the ignition system. Well, there's the cam and a crankshaft sensor. We have a third sensor. This looks a lot like it as well. It's also a magnetic sensor, but this is a vehicle speed sensor. Another two-wire sensor. It's got the mount where it mounts on. This will either be mounted like in the transaxle, the transmission. Sometimes these are even in the instrument cluster. It'll look a little bit different than this. But the same thing applies, and this actually sends a pulse to the computer to let the computer know how fast the vehicle is going. So there's three sensors there, but then we get into a couple of different ones I want to show you. For example, these are both temperature sensors. The computer needs to know what the coolant temperature and also the intake air temperature is. Now, why is that important? Well, in a carbureted car, you'd have the choke system, so whenever the engine's cold, naturally you need more fuel to allow the engine to run. Well, this is a coolant sensor, and if you look at the tip, this would be in the coolant stream, and what it does, it monitors the temperature of the coolant. And when the engine's cold, naturally it needs more fuel, and this is one way that the computer knows where the engine temperature is. As the engine warms up, it needs to have less fuel, and that's where this also comes into play. The incoming air for the engine, if you look at this, this looks a lot like the coolant sensor, except the thermistor on this is actually exposed. It's right there inside this cage. The cage is there to protect the sensor itself. The airstream actually goes past the thermistor and tells the computer what the intake air temperature is. We have another sensor, and this is used on some vehicles. This is a mass airflow sensor. And what this does, all of the incoming air it takes to run the vehicle goes through the sensor. And some of these mass airflow sensors will even actually have the intake air sensor will be combined in it. But if you look at this, as the air flows through that, there's even a screen on the back side of this. There's a thermistor inside there that actually tell the computer what the airflow rate is. This is very important for the fuel injection. A lot of times with this sensor here, it's something else you'd want to check if you had a trouble code for this. This sensor would be the air ducting going to it, because if you had a crack in the air ducting, naturally the airflow rate is going to be different. Two of the most common sensors that you're going to find and have a problem with, one is going to be the O2 sensor or the oxygen sensor. The reason for that is the O2 sensor, the tip of it, actually goes into the exhaust stream. So like when you take out a spark plug and look at the tip of the spark plug, after a period of time, naturally it's going to be worn, it's going to have some debris on the tip of it. The same thing applies to the O2 sensor since it is in the exhaust stream. Now the O2 sensor is kind of a unique sensor because it has the capability of creating its own voltage. What its job is to monitor the amount of oxygen in the exhaust system. If there's a lot of oxygen, it tells the computer that the engine's running too lean. If it has less oxygen, it's running too rich. So the computer's constantly monitoring this. This is a fuel control device. Now, if you look at this, a couple of the variances on a sensor, as you can see, this sensor here is a 4-wire sensor. This has a built-in heater element in it. What that means is the oxygen sensor will actually be preheated through a built-in heater. The reason that's important is this is going to be an inaccurate reading until it gets up to operating temperature. Another sensor we have to show you here, this is called a TP or a throttle position sensor, and this is a very important sensor, and these have a lot of problems because it is in fact a mechanical sensor. This actually hooks to the throttle shaft. Now the screwdriver would represent the throttle shaft either on the carburetor or on the fuel injection unit, and it's constantly rotating. There's a resistor inside of here, and as this rotates, it actually sweeps past that resistor, and that value is sent to the computer to basically let the computer know where the throttle angle is. Now, why is this important? Well, it'll tell the computer when the engine is at idle. For example, like on a carburetor, you have the accelerator pump that would bring a light from one circuit to the next. That's all done automatically with a TP sensor. It would be a smooth transition to like the voltage at idle to the voltage on wide open throttle. And this is really easy to check off of the car. Let me show you how to do that. Basically, all we really need is a digital volt ohm meter, and we're going to use the ohm circuit. And what we want to do is just actually check the resistance of the sensor itself. Let me get this set up here, and then I'll show you what I'm doing. Now, this is a 3-wire sensor, and what that basically is, it's going to have voltage, ground, and then the signal return from the sensor. Now, you've got a 12-volt system in your vehicle, but something unique about this sensor, and some of the others is it'll use like a 5-volt signal to this. So it's not a 12-volt sensor. You have to be very careful when you're testing these, especially if you're using what type of equipment you're using. You wouldn't want to apply 12-volt to it, so you'll instantly damage the sensor. So I've got the 2 leads hooked up to it. We'll connect them to our DVOM. There we are. Make sure everything's separated. We'll put this on our ohm scale. And what I want to do, I want to just basically take the screwdriver, put it in where the shaft's going to go, and I want to watch my DVOM as I turn the TP sensor. Now what I'm looking for is a smooth transition from all the way at idle to wide open throttle. And I'll tell you what, this sensor here has got a bad spot right off idle, about right there. And what you'll see on the DVOM, you'll actually see where the ohm reading will go open, like an open circuit. And that's what you want to look for. Now what this will do is, if you've ever had a problem with a TP sensor, what it'll do is you'll have like a flat spot and almost like a bad accelerator pump on a carburetor. So like you're at idle right there, and as soon as you touch the idle and get off idle, that's where this is open, right there. So what that would do is, at that instant, the computer doesn't know where the throttle angle is. So it has to try to compensate for this sensor. And then the bad thing about a TP sensor, it'll give you multiple kind of performance issues, because once you get past that point, like right there, then all the way up the rest of the way, it's fine. So just that one spot right there. Now this is the kind of things you want to look for. Now the way to know whether or not you have a problem with the TP sensor, this is where the trouble codes comes back into play. If you have a fault code for a sensor, there's a couple of different easy ways to check this, and then there's the most common problems, like for example, this would be the sensor itself. Well, like the TP sensor, like I mentioned, the O2 sensor is another common problem. Now the thing of it is if you have an O2 sensor code, just don't automatically replace the sensor. There's other things that can cause the code to appear. This is not a real inexpensive item. Something else to keep in mind is some vehicles can have up to 6 O2 sensors on it. The front ones are going to take care of the fuel control, but then you have the others in line. We have a vehicle here that does have an O2 sensor code stored in its memory, so let's go check it out.